Question 6, we're using these two special triangles. Now, I've replaced 30 degrees, 60 degrees, and 45 degrees with pi on 6, pi on 3, and pi on 4. So sine pi on 6, you can easily see 1 over 2. Sine pi on 4, 1 over root 2, which is the same as root 2 on 2 if you rationalise. Cos pi on 6, root 3 on 2. Tan pi on 3, this time opposite over adjacent, so root 3 on 1. Tan pi on 4, 1 on 1. Cos pi on 3, adjacent over hypotenuse, 1 on 2. Sec pi on 4, which is 1 on cos, so it's cos upside down. So cos pi on 4 is 1 over root 2. But because it's sec, it's this upside down, it's root 2 over 1, which is root 2. Cot is 1 on tan. So tan pi on 3 is root 3 on 1. So cot pi on 3 will be 1 on root 3, which is the same as root 3 on 3. Okay, these ones express in terms of pi. Now, if you're turning degrees into radians, you're going to times by pi on 180. So we've got 20 times pi on 180, which express in terms of pi. So when you do it in your calculator, you're just going to do where's this going to? We're going to put it in like this. Gives us 1 on 9, which means we're going to write our answer as 1 pi on 9. 225, 22.5 gives us 1 on 8. So we're going to change that to pi on 8. 36 gives us 1 on 5, so we're going to change that to pi on 5. 100 gives us 5 on 9, so we're going to change that to 5 pi on 9. 112.5 gives us 5 on 8, so we can change that to 5 pi on 8. 252 gives us 7 on 5, so we're going to change that to 7 pi on 5. These ones, if you're going from radians to degrees, you times by 180 on pi. So if we do pi on 12 times 180 on pi, the pi's are cancelled out, yeah? So 180 on 12 simplifies to 15 degrees. 2 pi on 5, 2 pi on 5 times 180 on pi. The pi's will always cancel out. So it's always the fraction times 180. 20 on 9, 400. 11 on 8, 247.5 degrees. 17 on 10, 306 degrees. And 23 on 15, 276 degrees. Now, we're going to use our two special triangles and our knowledge of angles of any magnitude to find these values. So if we've got sine 2 pi on 3, well, 1 pi on 3 is 60 degrees. So really we're finding sine 120, which is over here. So that's the same as 60 degrees back, but it's sine, so it's going to be positive. So it's positive sine 60, so pi on 3, which is sine pi on 3 is root 3 on 2. We've got cos 2 pi on 3. Oh, that was the same angle. So this time, no! This time it's cos 60, but it's going to be negative. And negative cos pi on 3, 1 on 2. Cos 5 pi on 6. 5 pi on 6 is in the same thing. So that's 5 lots of 30 degrees. That's 150 degrees. So it's 30 back this way. Instead of 30, I should say pi on 6. So it's a pi on 6 back this way. It's cos, it's negative. So that's the same as negative cos pi on 6, which is negative pi on 6 root 3 on 2. Tan 4 pi on 3. Now 4 pi on 3 is the same as, well, it's 4 lots of pi on 3, so it's 4 lots of 60, so it's 240 degrees. Which means it's pi on 3 down. Now we're in the tan quadrant, so it's going to be positive, the same as positive tan pi on 3, which is tan pi on 3 root 3 over 1. And it's positive. Okay. Tan 3 pi on 4. Now 3 pi on 4 is 3 lots of pi on 4. So we're here. We're in the sine quadrant, so it's going to be negative tan pi on 4, which is negative 1. Cos 5 pi on 3. Now that's 5 lots of pi on 3. So it's 5 lots of 60, which means it's 300. So we're around here, and it's pi on 3 down from the horizontal, because it's, just less than 2 pi, which is 6 pi on 3. So it's in the cos quadrant, so it's positive cos pi on 3. Cos pi on 3 is a half, so it's a half. Sine pi on 4. Sorry, 5 pi on 4. That's the same as 5 lots of 45 degrees. So we're here, and it's pi on 4 down. So this is in the tan quadrant, so it's negative sine pi on 4, so it's negative 1 on root 2. Or negative root 2 on 2 if you rationalise. Finally, tan 7 pi on 6. Now that's pi on 6, that's 7 lots of 30, so that's 2 tens, so that's down here. So that's pi on 6 more. It's in the tan quadrant, so it's positive tan pi on 6. Now tan pi on 6 is 1 on root 3. That's how we do question 11. The next question we're going to do on the advanced questions, it's question 13. On the extension questions, it's question 14. I believe for extension, I've written it as it's one of the development questions, but I want you to do it before 12 and 13. For advanced, this is a challenge question. So if f of x equals sine x, g of x is cos 2x, and h of x is tan 3x, find correct to 3 significant figures, these values. So for A, when they say f of 1, then that is sine of 1. When they say g of 1, that's cos 2 times 1. When they say h of 1, that's tan 3 times 1. So sine, cos, and tan. And every time you're just subbing in the 1 instead of x. So that's sine 1 plus cos 2 plus tan 3. They're saying correct to 3 significant figures. I assume we're just going to chuck this in our calculator. Make sure you do calculators in radians. Sine 1 plus cos 2 plus tan 3. That's not very nice at all. So it's 0.283. For B, we've got f of g of h of 1. Now, I'm going to unwrap from the inside. H of 1 is tan 3 times 1. G of 1 is cos of 2 times whatever you're subbing in. So that was my h. The cos of 2 times that And now if we do the sine of that, that's the f of that. So I just want to highlight these so the colours stick out better. I like my highlighting. Okay. I'm literally going to chuck it in my calculator as that. Sine of cos of 2 times tan of 3 times 1. Let me show you. So I did, hang on. Sine of cos of 2 times, and then we subbed in tan of 3 times 1. And close off the tan, close off the cos, close off the sine. 0.819. Okay, next question. So these are now just what I've put in as the enrichment questions for extension. So advanced students, you don't need to do these. What angle do the hour, minute, hands clock of a clock move through in 1 hour? So with a clock, 24 hours equals, no, not 24, 12 hours, we're just assuming a normal clock, equals 360 degrees. If we divide both of those by 12, 1 hour equals 30 degrees. If we want the minute hands, well, 12 times 60 equals 360 degrees, so this is minutes. If we divide both of these by 12 times 60, I can't be bothered figuring out what that is. We know 1 minute equals, so I've got 360 over 12 times 60, half, so 0.5 degrees. What angle do the hour, minute, hands, minute clock? Oh. Oh, well, in 1 hour, oh, sorry. I've just figured out, I think I've done one of the later questions. In 1 hour, the minute hand it moves all the way around, doesn't it? Find the non-reflex angles, so the inside angle, between the hour and minute hands of a clock at 2 p.m. So at 2 p.m, let's pretend we've got our clock. And here's and at 2 p.m, we've got the short one pointing there, and the long one pointing there. So the angle is we've got 2 hours in between them and 2 gaps in between them. There's 12 gaps all around, times by 360 degrees because it's 360 all the way around. So we've got 60 degrees in between them here. 2:15 and copy the same clock. This time though, our minute hand is pointing this way. I'm of course assuming that the actual hours hand is not moving, which it does, but that's going to make it way too complicated. So which is one of the reasons I don't like this question. So we've got 1/12 of the way around 360 degrees in between them. So that's 30 degrees. 230. This time the minute hand is pointing all the way down, and this is the angle. So we've got 4/12 times 360 degrees. $120 degrees. And finally 245. The hand's pointing this way. So we've got 5/12. Lots of 360. Which is 150 degrees between them. Now, we've got to convert all of these to radians. 30 degrees, of course, is pi on 6. 360 is 2 pi. 60 degrees is pi on 3. 30 degrees, pi on 6. 120 degrees, 2 lots of 60, so it's 2 pi on 3. 150 degrees, 5 lots of 30, so it's 5 pi on 6. Next question. The second hand of a clock turns in 7 seconds. So for A, we're turning in 60 seconds, we're turning 360 degrees, yeah? So in 1 second, we're turning 360 divided by 60, 6 degrees. So 7 seconds, we're turning 42 degrees. 42 times pi on 180 gives us 7 pi on 30 radians. Question B, the hour hand of a clock between 6 and 6:40. So it's moved 2/3 of the way around the clock. So we started off, at 6 a.m. we looked like that. But at 6:40 a.m. now, instead of being pointing straight downwards, we've moved 2/3 of the way towards 7. So we've got 2/3 time, lots of. Now this is 1/12 of the way around the clock. So it's moved 20 degrees, which is 20 times pi on 180, pi on 9 radians. And question C, the second hand turns in a week. Right, so it's turning 2 pi radians every minute. So we've got 2 pi times, well, there's 60 minutes in an hour, 24 hours in a day, 7 days in a week. So we're turning 20,160 pi radians. To 3 decimal places. Don't tell me I have to actually do this. So 7 pi on 30 is 0.733 radians. Pi on 9 is 0.349 radians. 20,160 pi is 63,334.508 radians. That question is the worst.